First of all, good afternoon, and thanks to the organizers for the invite. So my talk is more on to the simulation. Now I think previous presenters talked about basically on the EV technology and the range and then the load and all of those topics. So usually it was about kind of 4 to 5 years, but over the years it has the production time right from the design to the when the car comes out, it is decreasing over the years, and that shift left is happening everywhere. And now many of the OEs talk about 3 years, 2 years timeline, and China nowadays even talks about 18 months, right? So shift left is happening everywhere. And importantly, one of the aspects in that is like how do you speed up? How do you ensure that you have the quality vehicle coming out of your production facility and it is safe? And that's where simulation is extremely important. Recently, you might have heard about the Ford, Tesla, and also the BMWs, right? And the CEO of Ford recently mentioned that in the last 3 years, the cost of vehicle recalls to them is around 2.3 billion, right? It's huge. And the number of vehicles recalled by Tesla is also very high. It's not just the story of these, Teslas and the Ford, but all the top OEMs, including Stellantis, had vehicle recalls. And if you look into the the numbers, it is quite high. And also, if you look at some 150 years of whole of the vehicle produced so far, until 100, starting from let's say 2020s to the last 100 years, 150 years back, and then until then, the number of vehicle recalls are they are matching, right? I hope you have the slide. Okay. So, that is where simulation is extremely important. So what my presentation talks about is simulation, how you can ensure perfect, safe vehicle which reduces all these vehicle recalls. Now, when you talk about EV and then the range and all of those things, your charging infrastructure located across maybe a city, then how do you before you release the vehicle to the market, how do you check and verify that your design is safe, and then there are no vehicle recalls or there are no safety issues? So that's what I was talking about. Well, so all those top OEMs had a lot of vehicle recalls in the last few years. If you look at here, all of these guys are top OEMs, right? And we know that for all those top OEMs, the quality is extremely important, and that's what connects them to be the customers. Again, as I said, if you look into 2019 and backwards, and vehicle recalls since 2019, and that is equal, and so that's the amount of vehicle recalls which is silently happening. And also many of the cases, many of the occasions is also leading to legal complications. And you might have heard about Tesla's issues because of the radar sometime and all of those things. And also there were some issues with, I think some of the OEMs, they had issues with the battery management systems, which is also a software issue. And it is said that around 80% of the vehicle recalls as of today is happening because of the software. And yesterday, I understand that there were a lot of presentations, discussions on the software. So that's where simulation is extremely important, be it EV or your alternative energy sources like hybrid. This is extremely important. But let's quickly look into the trend, the market trend of simulation market. Because of the software, is kind of the simulation is increasing. The simulation, the market is increasing. I mean, it's expected to reach around 5 billion by 2030, and some people are saying that it's going to even increase exponentially. But in our region, like including Asia Pacific region, we are, in this particular region, we are growing faster than the global average. And that's because of the ecosystem around here. A lot of startup companies are providing a lot of solutions in that particular space. That's where it is quite increasing. Well, and everybody knows, I mean, in this automotive arena knows about NCAP, right? NCAP testing. And over the years, the NCAP testing is becoming quite tighter, and because the safety is very important. The mobility is always strongly connected with the safety. And NCAP guys are, every year, they're increasing a lot of test cases to ensure the safety. Recently, in 2020, I think NCAP 2023 talks about animals and the scooters, kids, and e-bikes, friction, and all of those things. Every year, the new test cases are coming in. And by 2030, I mean, the number of test cases is going to increase. And how many of these test cases can be really tested using a physical car? And it is humanly not possible. And so that's why even NCAP is saying that we want to test your vehicle, be it EV or hybrid or whatever it is, we want to test it, do those certification in a simulation environment so that you can cover almost all the test cases. Simulation provides you the scale, and it also helps automakers to shift left so that maybe they will achieve this 18 months timeline and also at the same time, the vehicles produced do not lead to kind of a vehicle recalls. So there is a major understanding within the OEs and also maybe the tier ones that they want to do 80%, 75 to 80% of the tests, high fidelity tests, accurate tests in virtual environment. And then 25% still they need hill and vehicle in loop and real vehicle tests. So that's the trend. How it is moving on right now. Well, I think there was a lot of discussion on ADAS and autonomous driving. So if you look, I mean, I just want to take this particular example because ADAS and autonomous driving is all about, a lot of software, a lot of machine learning, deep machine learning technologies embedded in it. And the level 0, is more of control theory, control engineering, and as you move towards is more of, so the Silicon Valley technologies, like a lot of software, people talk about continuous development, continuous testing, continuous integration, and you need a different approach to test all of those softwares. So earlier maybe you had very legacy way of testing. I mean, I can't really say legacy way. It's a kind of purely control engineering to software based testing. And then now all those, because of safety regulations, because of global safety regulations and also NCAP, a lot of sensors are getting inside, right? A lot of ECUs, and then sensors are getting inside. Now, if you look into some of the world's best safe cars, maybe, you have 8 radars, 8 cameras at least, and a lot of ultrasonic sensors, and with a lot of features like emergency brake assist, cruise control, parking, and on an average, that generates 5 TB of data per day. A car can generate 5 TB of data per day. And when you have so much of data coming out of the car, and the amount of, or maybe the scale or volume that need to be tested is increasingly high, that's where the testing effort really, really goes up. And that's why we need virtual testing. Now, importantly, what is the philosophy behind this virtual testing? Let me take the example of over-the-air updates, right, which is happening. Nowadays, everybody is planning to go for over-the-air updates because that also can help in handling vehicle recalls sometime. Now, even if there is a one-line change in some ECU or some, let's say that some steering or maybe battery management system, somewhere there's a one-line change, then that line change should not be just tested for battery management system for that particular component. What is more important is that the holistic testing from a system side, the entire vehicle should be tested for that particular one line of change. And that is a motto of virtual testing. So system engineering from day one, an engineer who develops that particular line of code should be able to test the change on his system given that particular entire vehicle model. So which involves digitally converting your physical vehicle into a digital twin. What do you mean by a digital twin? So you have tire, you have shock suspension, you have all of those components, your powertrain, ADAS. So all of those has to be converted into a digital model. So you have your tire models, you have your powertrain models, you have suspension models. So everything comes together, and then you represent the vehicle in a digital format. And then nowadays we also talk about like sensors. Now, every car, most of the cars now are, if you talk about the safety, is fitted with the radar. Then those sensors also should be modeled digitally, right? So you need to have high precision, high fidelity digital model of your radar, ultrasonic sensors or cameras. If you have LiDARs, then that also should be represented. What is more important is what is the fidelity or maybe what is the accuracy of that particular modeling. And these are all physics models. And there's a lot of research is happening over there, and a lot of universities are doing activities, and even in India, many of the startups and also organizations are focusing on how do we model every component of the vehicle digitally, right? And then there is a lot of collaboration among them. So when we have such modeling done, this is one of the scenarios. How does it look like? And we have taken it from a particular source, and this is a real scenario which is fed into used by some of the OEMs in India and also tier ones in India. So you can see that it is actually all of those things what you see are physics models. That's not animation. So the road surface you see is a physics model. You can change the conditions of that particular surface, and the vehicle and the truck over there is also digitally modeled, right? And all those tires and the suspensions and the motorcycle and the car, these are all digital representations, physics models, right? So when you have these kind of models, and then you can test your vehicle. I mean, car may be an EV car with BMS handled. I mean, BMS and also for example, if you want to test, I mean, previous speaker was talking about range and then the infrastructure and all of those things. And if you want to test all of those things, scenarios, you can use a that particular digital model of the EV car, and then put whatever the load, passengers, let's say that 200 kgs of weight inside that particular car, and then let's say you have you take Indian scenarios of, let's say, Jaipur or Ladakh and all of those things, digitally model all of those things and run the car and just then see what is the range, your particular configuration of EV batteries, and with that particular load, how much of a range it provides, right? Now, how is it done? I just want to touch upon the whole framework. Now, the testing is, as I said, from control engineering to software engineering. And what are the key ingredients of this software engineering approach? What you have is cloud. Basically, cloud gives you the scale, right? So you can have your hill. Of course, hill cannot be replaceable. You need hill, right? But cloud gives you, when you achieve the representation in digitally, you can always move on to the cloud. Cloud gives you, the scale. Let me talk about, like, let's say ADAS or autonomous driving scenarios. If you want to prove that autonomous driving is safe, maybe 20% or 30% safer than human driving, then you have to drive theoretically. A university published a paper which says that you have to prove it on 8 billion kilometers. Now, if you want to say that, if you want to prove the performance or safety performance of that autonomous car, then you have to run somewhere around 14 to 15 billion kilometers, which means that if you have a car, if you have 100 cars, let's say, and if you run that particular car 365 days in a year, then you need 400 years to do that, to prove that, okay, this autonomous car is safe, which is not at all possible, right? So that is not scale. But the moment you move digitally, if you get a digital twin and you run it on a cloud, cloud gives you the power, and then we also talk about ECUs. The first speaker also talked about security in ECUs, and then you represent all those ECUs also. There are many organizations which are working on now virtual ECUs, because when you produce a car, the ECU readiness happens towards towards the real end. I mean, if you're talking about the production life cycle, there are certain gates, and it happens towards the performance. And the developers do not have the hill or these ECUs on their desk to check the actual performance or functioning of the car. So if you have the controllers, microcontrollers, and the ECU very early in the stage, as you start the design, and then you have the ECU, and then you can generate the reports, and after that, if you can do a bit of vehicle in loop and the real world driving, but the 80% is here, and it is completely based on your continuous testing, continuous integration, just a very software engineering based approach, right? And then, as I talked about, the 14 billion kilometers requirement for autonomous driving. You are doing all those simulations in the cloud, or maybe cloud, and then using all those ECUs. And previous speaker also spoke about how green is your green technologies. Still, that question remains same, but the philosophers or the scientists say that there's a lot of carbon emission reduction if you go for digital twins, and if you simulate on the cloud. So that's it in a nutshell. And then let me quickly invite Aro onto the stage to talk about virtual EV challenge.
Hello. Hi. Thanks, Nagesh. Thanks for inviting me. Myself, Aurobindo from Robot Bosch. And I would also like to thank Yearly Times for organizing such an event where you are bringing all the EV minds together. So the idea here is to conduct an EV challenge in 2025. I think Nagesh has set the context of using the virtual environment for modeling the virtual vehicle and also the control functions, which are basically focusing towards how best we can make these EV vehicles for India region. So earlier this was done in Korea, but the focus there was on the AV, autonomous vehicle. But when we brainstormed, we understood that the need of the hour for the Indian region is for the electric vehicles, right? Because of the range anxietiness and then also the impingement of the electric vehicles in the Indian market is also needed. So the idea here is to provide an virtual environment to the competitors. So it means it will have the electric vehicle, and it's also possible to bring the software, simulatable software models in collaborations with the electric vehicles, and then it can be tested. So here the participant can register themselves as a team. It could be a team of 4 or 5. So where they bring their new functions, okay? Like for example, in India region, if you see in the traffic conditions, how the braking and then the energy creation, the electric machines and the braking should function, and also maybe the sensor informations, okay? It could be on the gradient, how the vehicle should perform, whether it should recuperate more or it should consume the power, looking at that there is an horizon where I can recuperate. So these kind of ideas the participant can test in the virtual environment. So this is basically focusing towards the student. I know there are a lot of startups and then the companies here who are also creating motors and then the battery technologies. So they can partner with the universities and then they can come into this competition, where we are trying to promote the young engineers in their, to enhance their innovations in the EV technology in terms of the range improvement, and then also the, as the previous speaker talked about, the infrastructure, like for example, when they plan their trip from A to B, if there are no charging infrastructure, how should they drive? Or if there is any charging infrastructure, how can they book the charging advance? Okay, maybe it could also bring in the cloud connectivity and then and the V2X topics. So please look forward for this EV challenge in 2025, and I really welcome you all. Thank you.
Yeah. The focus is basically to bring the students and then create that awareness and also use their innovative powers to enable it for Indian context. So thank you.